Hello everyone, this is Sravanthi, working as Assistant Professor, Department of Chemistry in Institute of Aeronautical Engineering. Today we are going to discuss about problems on calculation of air quantity required for complete combustion of fuel. So before discussing these problems, we'll discuss main points about this, how can we determine the quality of air or how much amount of air required for complete combustion of fuel. So we should remember main points about before that we solve the problems. So what is that? First, what is the meaning of combustion? So during burning process, fuel means it is a combustible substance. In the presence of oxygen, it produces heat energy. So this process is called combustion. So burning of fuel in the presence of oxygen. So in this case, it forms combustion products and also releases heat energy. So that energy is used for domestic as well as industrial purpose. So burning of fuel is called combustion. So this burning purpose, how much amount of heat required, how much amount of air required for complete combustion of fuel. So here, the main elements present in the fuels are carbon, hydrogen, oxygen and sulfur. So most of the fuels are containing these elements only: carbon, hydrogen, oxygen and sulfur. So on combustion of fuel, these elements are converted into gases. That means if in case in that fuel, carbon, hydrogen, oxygen, sulfur present in this case, it is reacts with oxygen or burning in the presence of oxygen. So carbon, if in case present it, carbon converts to combustion product is carbon dioxide. If in case hydrogen present in this fuel, it converts into water. And if in case sulfur present in that fuel, it converts into sulfur dioxide. These are the combustion products. Really, most of the fuels containing these elements only: carbon, hydrogen, oxygen and sulfur commonly. So during burning in the presence of oxygen, it produces carbon dioxide, water and sulfur dioxide, etc. So here, for efficient combustion, combustion means here burning of fuel in the presence of oxygen. So for efficient combustion, sufficient quantity of air must be brought. Here for efficient combustion, sufficient quantity of air must be brought into intimate contact with the fuel. It is most important. Burning of fuel, it is required must sufficient quantity of air is required for combustion of fuel. So here the amount of air and oxygen, required for the complete combustion of fuel. So it can be determined by considering the following points. So what are the points mainly we should remember before solve these problems? Depends on based on that how much amount of air required for complete combustion of fuel. So here the following steps must be followed to calculate the amount of air required for the complete combustion of the fuel. So here step 1 is write combustion reaction equation. First, you can write combustion reaction equation. For example, carbon reacts with oxygen. So in this case, it gives carbon dioxide. Or otherwise, sulfur reacts with oxygen, then it forms sulfates. So first write combustion reaction equation this way. And next step 2. So from this equation, calculate the amount of oxygen required by the elements or compounds present in the fuel. From this equation, calculate the how much amount of oxygen required by the elements or compounds present in the fuel. For example, here sulfur molecular weight is 32 and oxygen, its molecular weight is 32 and sulfur dioxide 64. Here 32 kg of sulfur, burning purpose, how much amount of oxygen required? Easily we know that 32 kg of oxygen required. Or otherwise, for example, carbon molecular weight is 12 and oxygen molecular weight is 32 and carbon dioxide is 44. So here what is the meaning? 12 kg of carbon, burning purpose it requires 32 kilograms of oxygen. So that is the meaning step 2. That first one is write the combustion reaction equation first this way. And second one is from this equation, calculate the amount of oxygen required by the elements or compounds present in the fuel. So which elements present in the fuel? So first we can write the reaction. From that reaction, we can identify the how much amount of oxygen required for complete combustion of elements or compounds present in the fuel. Next step 3. If oxygen is mentioned in the problem, if in case oxygen mentioned in the problem, that means already oxygen is present in the fuel. So that is mentioned in the problem. So it can be subtract. It can be subtract the weight or volume of oxygen. Weight or volume of oxygen already present in the fuel. Already present in the fuel. It is from total oxygen required by the other elements or compounds. So if in case oxygen present in the fuel, that means it given in this data already present in that fuel. So it can be subtract from total oxygen required by the other elements or compounds. This is step 3. And next step 4, since if in case nitrogen, carbon dioxide and water, if in case nitrogen or carbon dioxide or H2O, any other combustion products are present in this fuel, here that means do not burn. So they do not require any oxygen. So therefore, their values is mentioned in the problem. If in this case, it can be ignored. So what is the meaning? If in case, for example, nitrogen present in the fuel. So the data given in the data. So nitrogen doesn't have any calorific value. Doesn't have any calorific. That means it is not participated in this combustion reaction. So in that case, it doesn't require any oxygen. So if in case this value present in that fuel, it given in the data, in that case also we can ignore. The same way carbon dioxide and water also present in that fuel. So if in case given in the data, we can ignore because these two combustion products are not participated in combustion. It does not require oxygen for combustion. So that's why you can ignore if in case this percentage present in fuel. The next step 5 is finally calculate the amount of air required by the fuel. So here multiplying with 100 by 21 if volume. That means air containing 21% of oxygen by volume. By volume, air contains 21% of oxygen. Here it takes by volume. And 23% of oxygen by taking weight. Okay. So air containing 21% of oxygen by volume or 23% of oxygen by weight. So here finally calculate the amount of air required by the fuel by multiplying 100 by 21. 100 by 21. So if volume percentage, that is by taking volume, in this case we can write 100 by 21 with total amount of oxygen required. And total amount of oxygen required means if in case carbon present or hydrogen, sulfur or oxygen, in that case how much amount of oxygen required. And next, and 100 by 23 by weight, if you are taking by weight. So and also with total amount of oxygen required. And next step 6 is excess of air. Excess air for combustion. Excess air for combustion. More than the theoretical amount of air is necessary in practice to achieve complete combustion. It is most important. Excess of air are required. Necessary air supply is required for complete combustion of fuel burning. So this excess of air is expressed in percentage of the theoretical air. So I'm going to calculate this one. So theoretical air into 100 plus excess of air by 100. By using this formula, so we can calculate the excess of air is expressed in percentage of the theoretical air. That purpose we are using formula is theoretical air into 100 plus excess of air by 100. So we should remember these steps, all these steps. Before that, you can calculate how much amount of air required for complete combustion of fuel. So what is the first step? First you can write the reaction, combustion elements, combustion reaction. And after step 2, how much amount of oxygen required for complete combustion of elements or compound present in fuel. And step 3 is, if in case oxygen present in that fuel, we can subtract that oxygen from total amount of oxygen required for combustion of the fuel. And next step 4 is, if in case a non-combustible substance present in it fuel, if in case the data given in that problem, we can ignore because they do not participate, that doesn't have oxygen value. They do not participated in combustion reactions. And next one is, if in case we are taking by weight, we are using formula is 100 by 23. Or if we are using by volume, we are using the formula is 100 by 21 with total amount of oxygen required. Total amount of oxygen required. And last step is excess of air for combustion. So it is necessary for complete combustion of fuel. So when we calculated this one, theoretical air into 100 plus excess of air by 100. By using this formula, you can calculate the excess of air is expressed in percentage of theoretical air. These are the most important points for numerical calculation. How much amount of air required for complete combustion of fuel. Now let's discuss problems. So what is the first one? Our first problem, calculate the minimum volume of air. Calculate the minimum volume of air used for the complete combustion of a fuel. Complete combustion of a fuel. So they are having following composition by weight. So here it's given in the data. Carbon percentage is 90, hydrogen equal 5%, oxygen equal 3%, and ash 2%. Now you can calculate the minimum volume of air, not in weight, volume of air. So volume of air means air containing 21% of oxygen by volume. So here we can calculate the minimum volume of air used for the complete combustion of fuel. So first here, given that fuel by weight, we are taking here compositions. So percentage is converted into weight. So solution is coal containing 90% of carbon. So we converted into weight 0.9 kilograms of carbon. Next it containing 0.05 kilograms of hydrogen and 0.03 kilograms of oxygen and 0.02 kilograms of nitrogen. So finally here this given from this data, this is when we converted percentage to weights, because here we are taking by weight only. So fuel containing carbon percentage is 0.9 and hydrogen percentage is 0.05 and oxygen is 0.03 and nitrogen is 0.02, but we can ignore because it is not participated in combustion reaction. That means burning purpose, it doesn't require oxygen. That means not participated in combustion. So we can ignore this value of nitrogen. So now you can calculate the minimum volume of air. It is important, minimum volume of air required for the complete combustion of fuel. So here we are taking volume is air containing 21% of oxygen by volume. So here we are using 100 by 21 because we are taking minimum volume of air required for complete combustion with minimum amount of oxygen required for complete combustion of other elements. So what is that? Carbon. For example here 12 kilograms of 12 kgs of carbon requires 32 kilograms of oxygen according to reaction. So C kilograms of carbon requires how much amount of oxygen. So that case we are writing 32 by 12 into C. So already we discussed previous classes clearly. So why you are writing, how can we write this formula? And next hydrogen is plus 8 into H minus O by 8 plus sulfur. So this is a formula used for the minimum volume of air required for complete combustion of fuel. So now you can substitute the percentage of carbon, hydrogen, oxygen and sulfur in this formula. So then we'll get 100 by 21 into 32 by 12 into carbon percentage is 0.90. 0.90 plus 8 into hydrogen percentage is 0.05. Hydrogen percentage is 0.05 minus oxygen percentage 0.03. 0.03 given in the data. From the data, you can write all the values of carbon, hydrogen, oxygen, sulfur. We can substitute in this formula. So we'll get 100 by 21 into 32 by 12 into C carbon percentage is 0.90 plus 8 into hydrogen percentage is 0.05 minus oxygen percentage 0.03 by 8 plus sulfur here not mentioned. So its value are taking here 0. So finally take value is 13.19 meter cube according to volume. So minimum volume of air required for complete combustion is in this formula you'll get 13.19 meter cube by volume. Next problem is a sample of coal was found to contain carbon is 80% and hydrogen is 5% and oxygen is 1%, nitrogen is 2%. So the remaining being ash. So calculate the amount of minimum air required for complete combustion of 1 kg of coal sample. Complete combustion of 1 kg of coal sample. So here solution is 1 kilogram of coal contains. 1 kilogram of coal contains. So carbon percentage is 80. So we can convert it into weight, that means kilograms. So 80 by 100 equals 0.8 kilograms of carbon and 0.05 kilograms of hydrogen. So given coal containing 0.8 kilograms of carbon and 0.05 kilograms of hydrogen and 0.01 kilograms of oxygen and 0.02 kilograms of nitrogen. So nitrogen is non-combustible constituent. Already just we discussed. What is that? If in case nitrogen percentage present in this fuel given the data, we can ignore because it does not want and not require any oxygen. So the combustion reaction are, for example, so what is the step 1? What we should remember before solve this problem? First write step 1 is write on the reaction. Write on the combustion chemical reaction. So if it is carbon present in this fuel, so what is the reaction? Carbon plus O2 gives us CO2. What is the meaning here by weight? 12 kilograms of carbon. It requires 32 kilograms of oxygen. 12 kilograms of carbon requires 32 kilograms of oxygen. So here, in the same way, if in case hydrogen also present in that fuel, so hydrogen reaction is H2 reacts with oxygen then gives H2O. So here 2 kilograms of hydrogen requires how much amount of oxygen? 16 kilograms of oxygen required for 1 kg of fuel is burning. So next. So just discussing 12 kilograms of carbon requires 32 kilograms of oxygen from the equation. So in the same way, so in this given data, its carbon percentage is 0.8. So 0.8 kilograms of carbon requires. 0.8 kilograms of carbon requires. So here 32 by 12 into 0.8. So it's equal 2.133 kilogram per kilogram of oxygen. So 0.8 kilograms of carbon requires how much amount of oxygen? 2.133 kilograms of oxygen required. So in the same way, 2 kg of carbon requires. So here 2 kg of hydrogen requires 16 kilograms of oxygen. 16 kilograms of oxygen. That means, for example, H2 plus O2 gives a H2O. Okay, so here 2 kilograms of hydrogen requires 16 kilograms of oxygen. So in the same way, in this problem given that a fuel containing 0.05 kilograms of H2. 0.05 kilograms of H2. So in this case, it requires how much percentage of oxygen or how much weight of the oxygen required. So it's 16 by 2 into 0.05. So it's equal 0.4 kilograms of oxygen. 0.4 kilograms of oxygen. So now total amount of oxygen required. So here in that first carbon 0.8 kilograms of carbon requires 2.133 kilograms of oxygen plus 2 kg of hydrogen requires 0.4 kilograms of oxygen. So the total amount of oxygen required is 2.533 kilograms. 2.533 kilograms. But the amount of oxygen already present in the fuel. So from the data, amount of oxygen present in the fuel is 0.01 kilogram of oxygen. So what is that? The amount of oxygen already present in the fuel is 0.01 kilogram. So net oxygen required, it's equal. So total amount of oxygen is 2.533 minus already present oxygen in that fuel is 0.01. So it's equal, we'll get net oxygen required is 2.523 kilograms. 2.523 kilograms. So we know that 23 kilogram of oxygen supplied by 100 kilograms of air. 23 kilogram of oxygen supplied by 100 kilogram of air. So 2.523 kilogram of air is supplied by 2.523 kilogram of oxygen is supplied by equal by weight we are taking. That means air containing 23% of oxygen by weight. So you can write here 100 by 23. 100 by 23 into 2.523. So total net amount of oxygen is 2.523. It's equal, finally gets 10.9695 kilogram of air. 10.9695 kilogram of air. So the minimum quantity of air required for complete combustion of 1 kg of coal is 10.9695 kilograms. So in this way you can calculate the how much amount of air required for complete combustion of 1 kg of fuel burning. One more problem to discuss. Now calculate the amount of theoretical air by weight and volume required for complete combustion of 2 kg of coke. 2 kg of coke. So assuming 100% of carbon content. Assuming 100% of carbon content. So what is the solution? First write on the reaction, chemical reaction. Carbon. So carbon reacts with oxygen during burning process. It produces combustion product is carbon dioxide. So here 12 kilograms of carbon requires how much amount of oxygen? 32 kilograms of oxygen. 32 kilograms of oxygen. So weight of oxygen required. Weight of oxygen required for combustion of how much? 2 kg of coke. 2 kg of coke. So it's equal 2 into 32 by 12. So here 2 into 2 kg of fuel. So 2 into 32 by 12. Because 12 kilogram of carbon requires 32 kilograms of oxygen. So how can you write this? How can you calculate weight of oxygen required for complete combustion of 2 kg of coke? So in this case you can calculate it's equal 2 into 32 by 12. It's equal 5.333 kilograms. 5.333 kilograms. And next, amount of air required for complete combustion of 2 kg of coke. 2 kg of coke, it's equal. So how much amount of air required by weight? 2 kgs means by taking weight. So air containing 23% of oxygen by weight. So how can you calculate here amount of air required for complete combustion of 2 kg of coke? It's equal 100 by 23 into 5.333 kilograms. It's equal 23.2 kilograms. So next, volume of air required for a complete combustion of 2 kg of coke. So volume is air required by volume. So air containing oxygen is 21% of oxygen by volume. So you are going to calculate the volume of air required for complete combustion of 2 kg of fuel or 2 kg of coke. So it's equal 100 by 21 because air containing 21% of oxygen by volume. So you can write here 100 by 21 into and with a minimum amount of oxygen required for complete combustion of remaining elements present in fuel. So its value is 5.333. Just I calculated already. So it's equal 25.4 meter cube by volume. We are taking 25.4. So minimum amount of air required for complete combustion of 2 kg of coke is 23.2 kilogram. In the same way, amount of air required for the complete combustion of volume of 2 kg of fuel. The volume of air required for complete combustion of 2 kg of coke. So what is the value? 25.4 meter cube. Next, one more problem to discuss. So here fuel or fuel oil has the following analysis. So here carbon is 90%, hydrogen is 6, sulfur 2.5 and oxygen is 1% and ash is 0.5%. So calculate the quantity of air required for complete combustion of 1 kg of fuel if 30% excess air is used. 30% excess air is used. So here, what is the solution? So here given 90%. Solution. What is the here carbon present? 90%. So we can convert it into weight. That means kilograms. So finally we'll get after completing all the carbon, hydrogen, sulfur, oxygen, ash, we convert it into kilograms. Finally we'll get the coal containing 1 kg of coal containing 0.9 kilograms of carbon, 0.06 kilograms of hydrogen and 0.025 kilograms of sulfur and 0.01 kilograms of oxygen. Given in this data from the data. So weight of air required. So weight of air required means what is the formula we are using here? So weight that means air containing 23% of air by weight. So we can write 100 by 23. So here also same we are writing 100 by 23 and with the remaining how much amount of oxygen required for complete combustion of remaining elements present in fuel, that is carbon, hydrogen, oxygen and sulfur. So what is the formula here? We are using weight of air required 100 by 23 into 32 by 12 into C plus 8 into H minus O by 8 plus S. So we can substitute this a percentage of carbon, hydrogen, oxygen and sulfur what are given in this data. We can substitute in this formula. So then we'll get 100 by 23 into 32 by 12 into carbon percentage is 0.9. So we can substitute here 0.9 plus 8 into hydrogen percentage is 0.06. So we can substitute here 0.06 minus oxygen percentage is 0.01. So we can substitute here and plus 0.025 is a sulfur. percentage in that fuel is 0.025. So after calculation, you'll get 100 by 23 into 2.895. 2.895. So finally, weight of air required is equal 12.586 kilogram of air. Here I am using weight by weight. So its value is 12.586 kilogram of air required for complete combustion of 1 kg of fuel. Now let's discuss the amount of air required if 30% of excess air is used. 30% of excess air is used. So in this case, so what is the final weight of air required is? Weight of air required is 12.586 into 100 plus excess of air is 30. So we can substitute here 30 by 100. So it's equal 12.586 into 1.3. 1.3. So it's equal 16.362 kilogram of air required. So in this session we learn about how can we calculate the amount of air required for complete combustion of fuel burning. So what are the most important point before we calculate all these problems? What are the points we should remember? All are discussed in this session. I hope understood all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.